The first four problems from today's weekly contest. We're given the first problem, smallest number with all set bits. Here we are given number n which is positive and we are asked to find smallest number x which is greater than or equal to n and all of the bits inside x should be set. So if we are given suppose 10, if we are given 10 then its binary representation is 1010 and the smallest number x which is greater than equal to n having all set bits is nothing but 15. So we can use the formula. We know the formula 2 to the power number of bits, right, minus 1. Like this will give me the value that I'm looking for, right? That will be, in this case, it will be, so number of bits can be calculated using the log 2 base formula. Log base 2 of n plus 1 will be the number of bits, which is in this case 4. 2 to the power 4 will be 16, minus 1 will be 15, and that will be all set. So we can just calculate the formula. Power of 2 exponent will be number of bits, which is log 2 base n plus 1 minus 1 at the end. Since this can be double, let's make sure it is integer and let's submit it. It is straightforward first problem. Second problem, identify the largest outlier in an array. We're given a numbers array and there are 3 things inside the array. Not 3 elements, but 3 things. We have a couple of elements which are just elements. Next we have a outlier, or let me take outlier outside at the end. The second thing is this sum of the elements. So this is one value which denotes sum of these elements. Let me call this k, which is nothing but sum of elements. And then we have outlier which is contributing to nothing. And we want to find among all the elements inside numbers which is the outlier, and if there are multiple possible outliers we want the largest potential outlier, right? So we can iterate through nums, consider each particular value as an outlier, then the remaining value must denote something so that we can calculate k, and we can check if k exists inside elements or inside the numbers array or not. If it exists, then outlier is a valid outlier, and then we try the same thing for the remaining elements so that we end up with a largest outlier, right? So first we iterate through nums, consider every element as outlier. So if I consider this as an outlier, then the remaining elements will be nothing but elements and k. These are the remaining elements. And what if I sum these, which is nothing but 2 into k, right? This is nothing but 2 into k because elements is equal to k. So if I add them up, I will get 2 into k, which is nothing but total of the entire array minus outlier, right? So if I iterate through nums, consider every n as an outlier, I must have already gotten total before that, so I will iterate first and then get the total. So this is what I get for every element. I can check this, get 2 into k. and then divided by k, so it should be divisible by k. 2 total minus outlier must be divisible by k, should be divisible by k, and k, or should be divisible by 2, sorry, and k should be present inside nums, right? But we are also given inside the question here also says that we have outlier which can be also imitating any of these values. So it can be equal to k. So we must make sure that if the current outlier that we are considering is equal to k, then inside nums we should have at least two k's, right? So we must make sure that for that we need to have a count of every element so we can calculate a frequency and do the same thing. So that's the problem. Let's get the total first. Since we are going to iterate anyways, let's not use the accumulate function. Let's get a map. Here, this will be integer. For every n, we will update the frequency and add it to the total. Now our map and total is populated. Let's have an answer. Since we can have negative values and we want the maximum uh, potential outlier, so let's have minus 1001, since we, or let's have minus int minimum. All right, iterate through nums, consider each n as an outlier. So what I'll get is 2 into k by subtracting total with n. So let's get twice k variable and populate it with total minus n. So if twice of k mod 2 is equal to 0, that means we can get k by dividing it by 2. If map contains k, then we are good to proceed. There will be two conditions. First condition is if n is equal to k. Second condition is if n is not equal to k. That means n is not equal to k. If n is not equal to k, then we don't care about the frequency. It should be present inside map. That's enough. But if n is equal to k, then its frequency must be greater than 1. Right? Now, if this is true, then update the answer because this is a valid outlier. So let me update the answer and return it here. Let's see if this works. Time complexity will be O of n and space complexity will be O of n. Right? Okay, there is some problem. Total minus n is correct. Uh, if n is equal to k, then these two conditions must be true together. I don't know why they should be and. Alright, let's see now. Silly mistake. This works. The third problem, maximize number of target nodes after connecting trees, part 1. So we have a part 2 as well. Here we are given two trees and both are undirected trees, and we are asked to find, uh, we are given n nodes and m nodes in each, and we are told that we have a definition of target. So for every node, if we connect it with the other tree, so for tree 1, this is tree 1 and this is tree 2. If we connect tree 1 with any of the nodes in tree 2, then for that particular node, uh, from that particular node, how many other nodes we can visit such that the number of edges inside, um, between that path is less than or equal to k. Alright, so that's the problem, and we are asked to find the total number of target nodes that there is for every node inside tree 1. So my answer will contain 0, 1, 2, 3, 4. So the number of nodes inside tree 1 will be the size of my answer. And what the question is asking is, I want the maximum number of target nodes. So I want to connect 0 with any other node inside tree 2 such that I get the maximum number of target nodes. And how is it target node? Well, between, from 0, I can calculate or I can move k number of times or less than k number of times. Delete this. Let me take this as size. So if I choose this and I calculate the number of target nodes that is possible from 0. So I can go here, I can go here. Since the number of edges inside this path is 1, this path is 1, it is less than 2, which is k. So we are good. We get 2 target nodes, 3 target nodes, 4 target nodes, 5 target nodes, 6 target nodes. This is also good, 7 target nodes. This is because 1, 2 is less than equal to 2. 8 target nodes, and 0 to 0 is also a target node. So 9 target nodes. Alright, so we need to do this for every node. So for 0 we did this, for 1 we will need to do this, and similarly for other nodes inside tree 1 we need to do this and we need to get the answer. So what we really needed is a DFS from every node inside tree 2, right? So from 0, how many other nodes I can go to such that it is valid, right? So from 0, if I go to 2, it is good, 3, it is good, 7, it is good, 1, it is good, 4, it is good. This won't be good. This is not good because 1, 2, 3 is greater than k. So for 0, 1, 2, 3, 4, 5, 5 target nodes. Similarly, if I calculate it for every node, then essentially the maximum one will win. Suppose this is the maximum, this will win, right? Because anytime I connect, this one, I will get the maximum number of target nodes. So we essentially need to calculate the maximum target nodes for every node inside tree 2. and then we can do the same thing and populate our answer. So for 0, I'll do the same thing. I'll go to 1, I'll go to 2, I'll go to 3, I'll go to 4 if it is valid. Then all the ones that I get from here will be already stored inside max, right? And I can use that and add it to my answers that I get from tree 1 for this particular node. I'll do the same thing for every node. Alright, just that we need to be careful since we are considering this edge as well, or whatever edge between tree 1 and tree 2, so that will contribute to k. So for this one we'll take k as our threshold, but for this one we will take k minus 1 as our threshold because we have to give away one edge for the connection between tree 1 and tree 2. So that's the problem. First we will do a breadth first search. We can do this depth first search as well, but I'll do breadth first search. Calculate, since we are going to do similar algorithms for both tree 1 and tree 2, I'll create a function. But before that, we need to create the adjacency list. So let's create that first. Let's have a n, which is edges 1 dot size plus 1 int m, which is edges 2 dot size plus 1. This is n and m. It is of size 0 to n minus 1, so I'm taking one extra. For the adjacency list, we will have to do adjacency list. Let me call that edge 1 and adj2. For every adjacency list, I'm going to construct it, right? So let me construct adjacency list. For that, I will call a function. Let me call that construct, which will take edges 1 and which will create me the adjacency list. So let's construct adjacency list 2 as well using edges 2. Let me create the function first, which will return the list. Alright, it will take edges, so a vector of vector as an argument by reference. For every edge, it will have a adjacency list first so that we can return it. For every edge of edges, it will, since this is undirected, will take the 0th as the first node or the source node and the destination node, and the other way as well since it's undirected, and we can return the adjacency list. So we are good with the construction. Now let me, since we need to create or calculate the maximum distance, right, for the tree 2, let me create a max distance variable, max distance tree 2 variable, which will be initially 0. I'll calculate it for every node So I'll do a DFS or BFS function for every node, which will return me the integer or the maximum distance for that particular node, and I will globally maximize this variable. So max distance tree 2 is equal to max of max distance tree 2 comma BFS on the second adjacency list with starting from this particular node I with what with what the what should be the threshold to be compared against. That will be k minus 1, right? So let's create a BFS function which will return an integer denoting the maximum distance for that particular node with the adjacency list as the first argument. By reference, uh, second will be the starting node, third will be the threshold, which is k, or let me call it threshold. So initially the distance is 0, suppose we will have a queue. So let's create a queue of integer. Initially the queue will contain the start node. Since we should not revisit the node again, we should have a visited array, right? So let's have a vector of visited of size, adjacency list size, right? So now we are good to continue the loop until and unless the queue is exhausted. Uh, let's go level by level. So while size is present, get the node from queue front, pop it, reduce the size for every neighbor node. So let me go through the neighbor of adjacency node vector. If it is not visited, so visited of neighbor, if it is uh, not visited, so it's 0, then push it inside queue and mark it visited. Also, let's not forget to mark the starting node as visited. I forgot about that. I should have taken it here itself. All right. Okay. So for every level, after every level, increase the distance and check if the distance has gotten greater, or if it's still less than equal to k. If it is less than equal to k, then let's increase, let's have a variable answer which will be initially 1, because uh, actually it shouldn't be 1, it should be either 1 or 0. It will be 0, I'm sorry, it will be 0 if k is less than 0, because k can be 1 or k can be 0. So k minus 1 can go negative. So here if it is negative, then that means we don't have an edge, we just have a node. So in that case, I should not count my answer as 1, we should start with 0. So if k is less than 0, then keep answer 0. Or let me write it like this. If k is less than 0, then have 0 or have 1, and increment my answer by whatever the number of edges that we have inside Q right now. So Q dot size, Q dot size, alright. Else, if we have already crossed, past the threshold, let's break it and let's return our answer right here. So now that we have our answer, which means we have our max distance tree 2, now it's time to populate our answer, our result answer. So for that, we'll have a vector answer, which will be containing nothing. I'll iterate through, sorry, not nums, I'll iterate through all the nodes. So from I, from 0 to n for that first tree, I'll iterate for every node, and I will push inside the answer the same BFS function that we were doing, plus the max distance of tree 2, right? So BFS of I comma ADJ 1, sorry, let's go in order. ADJ 1, since we have first parameter as the adjacency list, the node, and the threshold. This time it will be k, not k minus 1. And we are good. Let's return answer. That's it. Let's see if it works. It doesn't. This is threshold, and I'm using k. Let's update it. Now it should work. Okay, my bad. Something is wrong here. So we are constructing the list. Let's see if I am reaching here. Okay, I'm not even reaching here. Let's see the construct function. Okay, this looks good. This should be working. Let's see if I'm reaching this till this point. Okay, I don't think I'm reaching this point. The adjacency construction is where things are going wrong. Let's make sure this is correct. Oh, my bad, my bad, my bad. I am not populating or no, initializing the size. It should be initialized. Let's see now. Silly mistake. Okay, this works. Yeah, this works. Since so the time complexity, since we are doing a BFS, which is a O of one operation or O of n operation already, and we are doing it for every of both the tree and for all the nodes. So we are going to have a time complexity of n square plus m square. which works, but we can do better here as well. And that's why we have a fourth problem, which is the part 2 problem, which is a little bit different actually. I think we'll look at it in the next video. Thanks for this one.